In this problem, we are given a mechanism that consists of a cylinder and drum. The cylinder has a mass of 8 kg and it has a velocity of 0.3 meter per second, while drum has a mass of 12 kg and the value of centroidal radius of gyration is 210 millimeters, while the radius of the group of drum is 200 millimeters. And the frictional moment at the center of the drum is 3 Newton meters. So we have to find the value of the velocity or speed v when the cylinder is dropped 1.5 meters. And for this, we are using the work energy relation that says initial kinetic energy plus work done is equal to final kinetic energy. So let's say this is our equation one, and you see that the cylinder is performing a linear motion while the drum is performing an angular motion. So the kinetic energy equation is 1 divided by 2 mv square plus 1 divided by 2 iw square. So here I is the moment of inertia and it is equal to m multiply k square, while the w is equal to v divided by r. Because you see, we can relate angular velocity with linear velocity by the formula that is v is equal to rw. So here w becomes v divided by r. And you see we have a term that is general plane motion, but we will discuss this in some next lecture, but I will add its detail in the description so you can check this. And now you see that the cylinder performs a work that is equal to Fh, while the drum performs a work that is equal to m theta. So the work done by this mechanism is equal to Fh plus m theta. And as you see, the force of gravity is acting on this cylinder. So here force becomes mg. And here you see we have another formula that is H is equal to r theta, and here h is the arc length while theta is the angle substituted by the arc at the center of circle. So here theta is equal to h divided by r. And now we are going to find the initial and final kinetic energy values. So for initial kinetic energy, we have the mass of cylinder that is 8 kg, the initial velocity of the cylinder that is 0.3 meter per second, the mass of drum that is 12, and the value of k is 0.21 meters. And again, the velocity of cylinder that is 0.3 and the radius of drum is 0.2 meters. So we get our initial kinetic energy value that is equal to 0.995 joules. And for final kinetic energy, again, we have the value of the mass of cylinder that is 8, the mass of drum that is 12 kg, the value of k that is 0.21, and the radius of drum that is 0.2. So we get a final kinetic energy value that is equal to 10.62 v square. And now for the work done, that is equal to Fh plus m theta. So we have the value of mass of cylinder that is 8 kg, the value of the force of gravity that is 9.81, and the value of h is 1.5 meters, and the value of frictional moment is 3. Again, the value of h is 1.5 meters, and the radius of drum that is 0.2 meters. So we get the work done by this mechanism that is equal to 95.2 joules. And now we are going to put all these values in the equation one, that is the work energy equation. So we get 0.995 plus 95.2, that is equal to 10.62 v square. So through this we get the value of velocity that is equal to 3.01 meter per second. And that's all for this video. See you in the next lecture.